And action. There we go. Blast off. There we go. So what we're going to be talking about is more trigonometry. But before we get really hard into trigonometry, let's go ahead and review a little 30, 60, 90 problem right here. Okay? So we're going to solve this using the 30, 60, 90 and the 45, 45, 90. But we're also going to use trigonometry to show you how trigonometry works to be able to solve this if you forgot all of the ratios of the 30, 60, 90. So the first triangle I want you to look at is this triangle right in here. Now there's the 30 degrees. Now, which side is directly across from the 30-degree angle? 8 radical 3. So what I'd like you to do is, on your paper, just write 30, 60, 90. Practice your ratios. X radical 3, 2x. And where does that 8 radical 3 go? Which angle is that directly across from? The 30. So put that right here. Put 8 radical 3. Because that's directly across from the 30-degree angle. Now, what do I have to do with this 8 radical 3? I have to take 8 radical 3 and multiply. That's what x is, right? We got to multiply it by radical 3. So how in the world do you multiply 8 radical 3 times a radical 3? What happens with these radical 3s? Yeah, well, the radicals cancel out. And so basically it becomes 8 times a 3. And 8 times 3 is 24. So that's what we're going to put right here. Now where do I put the 24 on this triangle? I put the 24 right here, because that 24 is directly across from the 60-degree angle. So you'll see how it's across from the 60-degree angle. Now, why did we do that? The reason we did that and wanted to find that side is we need to understand that that 24 is actually the hypotenuse of the 45, 45, 90 triangle that's directly below it. So we have this side. We found the 60-degree side because we're going to now use this 24 right here because it's directly across from the right angle. So now what kind of triangle do I have now?
45.
That's right. Practice it, right? 45, 45, 90, x, x, x radical 2. Now remember, where is that 24? That 24 is across from which angle? 90. So you put 24 right here. Now there's 2 steps, if you don't remember. There's 2 steps to work our way back. I'm going to write here, we'll put solve for x. You should have these 2 steps in your journal. Divide by, well actually divide by 2 or multiply by a half. So I'm just going to put take half. Alright? Take half of your hypotenuse. Right, so take half of the hypotenuse, which is going to be what? Half of what number? 24, which is going to be a 12, right? So then take the 12 and multiply by 12 multiplied by radical 2. And that gets you your answer. So your answer for the x is 12 radical 2. So these are the 2 steps. To go from the hypotenuse back to the leg, all you have to do is what? Take half of it and multiply it by radical 2. What does that mean? That means, ooh, I just found x. X right here, this side right here is equal to this side right here. So I'm going to put a 12 radical 2, and I'm going to put a 12 radical 2. And right up here, where it says solve for x and y, right here, I'm going to put 12 radical 2. All right, not that we need this for this particular problem, but what would my 90-degree side, what would my hypotenuse be for this triangle? What would it be? Not that we need it, but what would it be? 16 radical 3, right? It's double whatever that side is. Okay? So this side, even though we don't need it, okay, just good to know, that distance is 16 radical 3. Now what we're going to do is we're going to look at the final triangle, right? So we're going to look at the final triangle right here. So do I have the length of this side of the final triangle? I do. It's what? It's 12 radical 2. Now, you see the 60-degree angle right here? That's not opening up to that side. It's actually this angle. So if that's 60 degrees and this is 90 degrees, what does this corner have to be?
30.
30. So right now in red, I'm going to make another chart, right? Make another chart. 30, 60, 90, x radical 3 and a 2x. And what am I going to put right here for my shortest side? My shortest side was, or is, sorry, 12 radical 2. Now what are we trying to find? We're actually not trying to find the 60 degree side this time. What are we trying to find? We're trying to find the side that's across from the 90. And so how do I go from here to here? All I have to do is do what? Just multiply by 2. So what's my final answer for y? 24 radical 2. And by the way, what would my 60 degree side be? What's a radical 2 times a radical 3? Radical 6 is right. So right here, if you would please, put 12 radical 6. Now we didn't need to know that, but this side right here, just so you know, if I change the y and put the y from here to up here, then your answer would be 12 radical 6. Now, Sierra, help me out. Give me an approximate value of 12 radical 2 and give me an approximate value of 24 radical 2. So 12 radical 2? 16.97?
Yeah.
Okay, so we're just going to round it up to a 17. Okay? What about 24 radical 2? 33.9. Okay? So right here we have it's really close to a 17 and really close to a 33.9, really close to a 34. Now what I want us to do right here is we're just going to take one triangle, okay, and show you that you can actually use trigonometry to solve it. So right now, this triangle right here, I'm just going to recreate it real quick. I'm not going to do all the triangles. I'm just going to show you what if I use trigonometry instead of all the properties of a 30, 60, 90. So let's pretend right here that this is your right angle. This right here is still 30 degrees. This side right here is still 12 radical 2. And this is still the hypotenuse. Now, what we're going to do is we're going to try to solve for the hypotenuse. I'm going to still call it y. But this time we're not going to use the properties of the 30, 60, 90. We're going to use trigonometry. Now, what's the very first thing I want you to do when you're solving these? I want you to draw an arrow from the angle that you have. So our arrow is from the 30 degree angle. So this arrow right here is across from, pointing across to my opposite side. So what I'd like you to do is label this. Label this your opposite side. This is your hypotenuse. So if we were to use trigonometry, what are the three ratios? You have SO, Ka, and To. Now let me explain to you how we're going to be using these. So, my forward will work. Here we go. So, Ka, To. Now, So, Ka, To. All right? By the way, what do we have? We have our opposite side. What do we need to find? We need to find our hypotenuse. So this is dealing with the O. This is dealing with the H. Which is the only one that deals with O and H? Which one? You see an O and an H. Ah, that lets you know this is what we're using. So you look for what you have, and then you look for what you need, and that determines which trig ratio you're working with. So we're going to work with sine. So here's what you're going to write. You're going to write the sine of our angle, and our angle is 30 degrees. So the sine, what always goes here? You're going to put the sine of the angle. Get it spelled. There we go. Angle. There's the sine of the angle. And what is that going to equal to? That's going to equal my opposite side, which is 12 radical 2 over the hypotenuse, which is a y. This is our relationship of O versus H. Now, this is a ratio, a comparison of two numbers. I'm going to put this over a 1. Now look what happens when we cross multiply these, all right? When we take our cross products, what do we get? We get y times the sine of 30 equals 12 radical 2 times 1. 12 radical 2 times 1 is just 12 radical 2. And what are we trying to solve for right now? We're trying to solve for our y value. So we have to divide both sides by the sine of 30. Now, what I'd like you to do in the calculator right now, in the calculator, let's type it in and let's see what our approximate value is. So get your calculator. All right. Now, when you're using the calculator, make sure your mode, where it says mode, make sure you're in degree mode. Because if you're not in degree mode, it won't work well. It won't work at all. All right. There's a difference between. We'll get to radian mode eventually. Right now, we're going to be doing degree mode. Now, after you get to degree mode, I'm going to do alpha y equals enter, and in the numerator, I'm going to type in 12. Radical 2. And in the denominator, what did we divide by? We divided by the sine of what? Sine of 30. I'm going to press enter. Now, by the way, what did we get? 33.9. Now, what did we say that was approximately? What was that? You see that answer right there? It matches, all right? So 24 radical 2, that's the exact answer. Okay? What was the approximate answer? 33.9. What did we do differently on this one? We didn't use the 30, 60, 90 triangle. We used the properties of sine instead of using trigonometry. Okay? So that's what we're going to be doing more today. By the way, check your mode button. Make sure you're in degree mode. All right, moving on to the next problem. Here we go. It says, Kyla draws a line, N, on a coordinate plane. What angle does N make with the x-axis? So what I'd like you to do right now is make sure that you understand the x-axis is right here, all right? And this line makes an angle with it going up. And what we're going to do is we're going to call this angle right here. We're going to use the Greek symbol theta right here. Theta represents the measure of the angle. Now there's two different triangles that you could build out of it. Does everybody see this little tiny sliver of a triangle right there? Okay, that's one of the triangles. Okay, but you could also keep going and make a little bit larger triangle to see it better. And I'm going to go ahead and just use that one because it's a little bit easier for people to see. All right, so let's think about this triangle. I'm going to cut it off right here, make a right angle. So here's the measure of our triangle. I'm just kind of copying it right here. How far does it go over? It goes over 1, 2, 3, 4, 5, 6, and it goes up 2. Now, does everybody see how the small triangle, you could have used what? You could have used another triangle and made a what? Not a 2 by 6, but a 3 and a 1. Understand that the measure of this angle will match the measure of this angle. And theta is the Greek symbol that we're using for the measure of an angle. So this is going to be something I'd like you to put into your journal right now, because if you want to know how to find the measure of an angle just knowing two sides. So we're going to find the measure of an angle. So we're going to solve right here. We're going to solve for theta. All right, so we're going to go over strategy real quick. All right, here's my strategy. I always go from an angle. The very first thing, after I find the angle that I'm looking for, all right, I draw an arrow. And the arrow always helps me remind myself of what my opposite side is. So that helps me label. So why do I draw the arrow? Because it always labels my opposite side. Now, everybody should know that this side is your hypotenuse. That's the longest leg of a right triangle, which means this 6 would have to be my adjacent side. So what are the two pieces of information that I actually have? I have my opposite side and I have my adjacent side. So after you realize which ones you have, then you look at your 3 trig ratios that you should have memorized, and then you figure out, which one am I going to use? The so, the ka, or the toa? Which one do you think? You're right. Because that's the opposite and that's the adjacent, so we're going to use toa. So that's how we figure out which trig ratio we're going to use. Okay? Here's how you solve the problem. You're going to write the tangent of theta equals the relationship of my opposite side, which is a 2, over my adjacent side, which is a 6. Just remember, this is what? This is the opposite side, this is the adjacent side. Now, this is the most important part. In order to find an angle, you have to use, this is the only time you ever use the inverse of whatever, either a sine, cosine, or tangent. We're going to be using the inverse of tangent this time. So watch what I'm going to do. I'm going to apply what's called the inverse of tangent on one side, and I'm also going to apply, it's kind of hard to see, but right, the inverse of tangent. It's supposed to be tangent to the negative 1 right there. Okay? Because what happens is these will cancel out, and you're able to find theta. These multiply together to equal a 1. And theta will equal the inverse of tangent of the ratio of 2 over 6. Which this ratio is still equal to what? 1 over 3. So go to your graphic calculator. Type in, that's how you type it in. You hit second, and you hit the tangent button. And you type in 2 divided by 6, and you press enter, and you get that measure, which is 18.4 degree angle, which is our answer. But look what happened if you did the, if you used the ratio of what? 1 over 3. You could have used either triangle, and it would have still worked, because it's the same ratio. So what's our final answer for this particular problem? 18.4. Yeah, round your, now it says round your answer to the nearest what? To the nearest degree. So if you got 18.4 degrees, the nearest degree would be 18 degrees. Alright? So what we did over here, we found this to approximately equal 18.4 degrees, and then we rounded it to the nearest degree for our answer. So that's the measure of this angle. Alright, now that we've practiced that, let's go ahead and just do a problem right now. Let's go ahead and let's do problem number 10. So right now, we're going to do problem number 10. I'm zooming in. You don't have to put this in your journal, but you guys are going to call out the steps that you're going to think I'm going to do. Alright? So the first step, I'm going to make an arc right here. That's my angle. That's my perspective. I'm trying to solve for x. What's the next thing you think I'm going to do if you had to make a prediction? Draw an arrow. Very good. So I'm going to draw an arrow. And what does that arrow tell us every single time? That's my opposite side. Very good. So that's my opposite side. So I label my opposite side. Then what's the next side that I always look for? Now, I don't look for my adjacent. I always label the one. Yes, I always label my hypotenuse, which means this side would have to be my adjacent side. So what's my step? Find your opposite side. Label the easiest side, which is your hypotenuse. That's always across from what angle? That's always across from the 90-degree angle. And what's the last thing I always label? My adjacent side. So, draw an arrow. Label your hypotenuse. Label your adjacent. Now, let's think about it. What do we have in this particular case? We have our hypotenuse and we have our opposite side. So you write your trig ratios down. So, toa, and you go, which one am I going to use? So, you're right, because we have our what? Opposite side and we have our hypotenuse, so that's why you choose sine. Okay, so here we go. So now we know that we have sine. All right, so we're going to write. Ready? The sine. That's a horrible sign. Here we go. The sine of. What am I going to put right there? X degrees. That's the measure of our angle that we're trying to find. That is going to equal the ratio of our opposite side, which is 9, in relationship to the hypotenuse, which is a 31. So just remember, I'm comparing what? My opposite to my hypotenuse. That's what I'm comparing. So there, that's how you set it up. Now that's not my final answer. Okay? What do I have to apply to both sides? I have to apply the inverse of sine. So when you apply, right here, I'm going to do it really, really, really tiny. If I apply the inverse of sine to this side, and I apply the inverse of sine to this side, when I multiply that, what happens? These cancel out, and x degrees will equal the inverse of sine times whatever 9 divided by 31 is. And that will give me the approximate value of my angle. So there we go. You're going to hit second, and this time you're not going to hit second tangent, you're going to hit second sine, and do 9 divided by 31. And you're going to press enter. Sweet. That's 16.87, so if we wanted to round it to the nearest 10, that's what? 16.9 degrees. And we're rounding these all to the nearest 10. And that's the answer to the measure of your angle. We're going to do one more problem, and then we're going to let you guys start doing this on your own. Now, what have we been finding right now? We've been finding the measures of angles. So we're going to now do the next, actually the easiest thing, which is finding the measures of, let's do this one. Do number 11. Put number 11 in your journal, because this time we're not trying to find the measure of an angle. We're trying to find the measure of a side. So here, we're going to go from two different perspectives. We're going to go from this perspective, all right, which is my 40-degree perspective. Yeah, that's right. So, yeah, so hold on. Let me get this colored in. But you're right. Hold on. Here we go. We're going to draw the, go ahead, draw the arrow. Now, what does the arrow do? That labels my opposite. And then you said we're going to label my hypotenuse. And the last thing we're going to label is the adjacent. There we go. Just like that. So here are the two questions you have to ask yourself. What do I have and what do I need? What do I have? I have the adjacent side. What do I need to find? I need to find my hypotenuse. So this one is dealing with the A. This one's dealing with the H. So I'm going to write toa. I'm like, which one are we going to use? That's right, because that's the relationship of the adjacent to the hypotenuse. So now, how do we set this up? Here we go. Before we did what? We said the cosine, and then what's always going to go right here? This, the measure of the angle. So which angle do we have? 40. So you put 40 right there. And that's going to equal the relationship of my adjacent side, which is a 32, over my hypotenuse, which is an x. Remember, that's the A, that's the H. So this is your equation, okay? Here's your equation that you set up. Now I'm going to move over to the right a little bit so we have a little bit more room to work. So we're like, okay, great. What do I do now? So I'm going to put this over a 1. I always like to put this over a 1. And that allows me to set up my proportion, which allows me to use my cross products. So I'm going to multiply these right here, because the cross products in a proportion are always equal to each other. Okay? So one of my cross products is an x times the cosine of 40. And the other cross product is 32 times a 1, which is a 32. So I'm almost done. What's the only thing I have to do to solve for x in this particular case? I have to divide both sides by what? Not by 32. By the cosine of 40. Now the reason why I'm dividing both sides by the cosine of 40 is I'm trying to totally get x by its lonesome, by itself. Where it's, all you see is what? All you see is an x. And these cancel to a 1. And so whatever 32 divided by the cosine of 40 is equivalent to is the length of my side. That's what the answer is. So we're going to go to our calculator right now. There's two ways you can type it in. Ready? Here's one way. You can type in 32 divided by the cosine of 40.
Yeah.
That's one way to do it, just like that. By the way, if you're wondering why I'm talking like this, there was an all sports announcer. His name was Howard Cosell. Since we're using cosine, figure we talk a little bit like Howard Cosell. He's long since passed away, but he was one of my favorite announcers. Now, the other thing you could do is you could do alpha y equals enter. And you do a 32 up here, and you put the cosine of 40 right there. You know what? I'd have to look up where Howard goes. You know what? He probably was from the New York area.
No.
We'll have to look it up here in a little bit. Okay? But one of his favorite people to interview was Muhammad Ali. He and Muhammad Ali had one of the greatest interviews of all time. Is Muhammad Ali and how it cosine. You should look it up. You should Google it. Watch it. You'll be entertained forever. Now, by the way, you guys see how these are, you typed it in two different ways, right? And you get the exact same answer. Now, remember, this is not degrees. Did we use the inverse button? No. This is the length of the side. So 41.8 units is your answer. 41.8 units. Let me go back to our figure. Right here. So what is x approximately equal to? 41.8 units. Which, if you think about it, makes sense. If that's 32, we know our hypotenuse has to be what? Has to be bigger, right? So that's a reasonable answer. Okay? Now, go ahead if you need to go. All right, I think let's do one more problem for the recording, and then we'll call it a day. All right? Let's see here. 14? Yeah, we can do. You know what? Let's do an easy one. We'll do 14. We'll do 14. Here we go. We'll do 14. This will be our last one. All right, so let's think about what we're dealing with. Okay, here's our angle. Right? Here's our angle. What are we going to do? We're going to draw an arrow going across. And what does that help us locate? That helps us locate the opposite side. Ooh, the 19 is directly across from the 90-degree angle. So that's our hypotenuse, right? That's our hypotenuse. And x, what is that going to represent? That's going to represent our adjacent side. Now, so what do we have this time? We don't have our adjacent side, but we do have our h, which is our hypotenuse. And what are we looking for? We're looking for our adjacent side, which is a. So what trig ratio are we going to use? That's right. We're going to use cosine 1/60. All right? So since we're using cosine, we're going to do this whole problem to memorialize how it cosine. All right? So hopefully he's not rolling over in his screen. Here we go. We're going to write the cosine of what angle right here? What's the angle we're dealing with? 33 degrees. And that's going to equal my adjacent side over the hypotenuse. What is my adjacent side? What is my hypotenuse? 19. I really like this because this is really, really, really easy. What are we going to put this sucker over?
33.
Over a 1. Because we're setting up what's called a proportion. So here's your proportion right here. And what do we know about the cross products of a proportion? What do we know about the cross products of a proportion? They're always equal. That's right. All right. So tell me one of my cross products, Daisha. Tell me. What's one of my cross products right there? X. You chose the easy one. I like it. All right. What's my other cross product, Kyla? She stole the easy one. X times 1. What's the other cross product right there? Start with the 19. And what are we multiplying that by? That's right, the cosine of 33 degrees. Hey, did we have to divide this time? This is the easy. When you don't have to divide, it's just boom, you're done. Just type in 19 cosine 33 and you're done. And that's all you have to do. 19 cosine 33. Hit enter and say, boom. There you go. It's 15.9 units. And that's all you got to do. So what's x approximately equal to in problem number 14? 15.9, and what are you going to write next to it? Units. That's right. There you go. So we just did one where you didn't have to divide, and we did one where you had to divide. Here's the one that you had to divide both sides by the cosine. On this one, you didn't have to divide a single lick in the whole problem. It was easy. All right? All you got to do, either you're going to have a easy one or a slightly more difficult one. Have a good day. Hope you learned something. If not, go to sleep.